Hello viewers. Today we have a treat for all of you who are familiar with both Python and Django. If you have been working with these technologies for some time and are looking to take your skills to the next level, this tutorial is for you. We will be diving into the advanced techniques available in Python and Django and showing you how to use them to achieve advanced functionality. By the end of this tutorial, you will have a deeper understanding of what is possible with these technologies and how to apply them in applications. So get ready to learn and expand your knowledge on Python and Django as we take you on a journey to the next level. If you're enjoying my content, I would be so grateful if you could subscribe to my channel and like my videos. Your support means the world to me, and it will help me continue to create even more tutorials for you. Thank you so much, and I look forward to bringing you more videos in the future. So let's get started. Some of the most advanced techniques in Django are related to the way Python constructs its classes. This process is often taken for granted by developers, which is understandable, but it forms the foundation of Django and is therefore an important aspect to examine. When the Python interpreter encounters a class definition, it processes its contents just as it would any other code. As a result, a new namespace is created for the class, and all the code within it is executed. Class definitions typically consist of variables, methods, and other classes, which are essentially assignments to the namespace of the class. However, nearly any valid code can be included in a class definition, such as printing to the console output and writing to log files. Let's use the Python shell to see an example of a normal Python class. Open the terminal window by clicking on View and choose Terminal in the drop-down list, or by using this keyboard shortcut. In the terminal window, type Python and press Enter. This will launch the Python shell, and you will see this prompt, which indicates that you are now in the Python shell. Start to add any type of a Python class that you remember. I will choose this one. Don't forget to use the indentation using the Tab key. Inside the class, add print statement to print any string. Let's add a variable. Add another print statement. Hit twice the Enter key on the keyboard. As you can see, code executes within the class definition. Once the class is ready, any assigned variables will show up as a class attributes. What is a metaclass? A metaclass is a class that defines properties of other classes. With a metaclass, we can define properties that should be added to new classes that are defined in our code. In the previous section, what we've been engaging in is called metaprogramming. Metaprogramming is a programming technique in which programs have the ability to treat other programs as their data and modify or generate code at runtime. It involves writing code that manipulates or generates code, rather than just executing it. To help illustrate how the metaclass arguments are derived from a class definition, take the following code as an example. Type is actually a metaclass, a class that creates other classes. Using type manually makes it possible to create classes with duplicate names, and even to customize the module location by providing a module key in the attributes argument. The constructor for type can accept 3 arguments, which represent the entire class declaration. It accepts the name which is provided for the class as a string, bases, which is a tuple of classes in the inheritance chain of the class, and attributes, which are dictionary of the class namespace. The constructor will print the class definition. The class name. The class bases. And the last, but not the least, the class attributes. As I've mentioned before, the class attributes is a dictionary. That's why I am going to use the iterator to get the name of the attribute and the value of the attributes. Notice that the class wasn't instantiated at any time. Let's create another class which will inherit every attribute of the metaclass that we've just created. Here we are making this class to inherit every attribute of the metaclass. Notice how the simple act of creating the class triggered the execution of the metaclass. Notice module in the list of attributes. This attribute is a standard part of all Python classes. Metaclasses can be quite useful, but the metaclass option is an implementation detail that shouldn't need to be a part of the process when defining classes. Another problem is that although each class is processed by the metaclass, it doesn't inherit from any concrete class. This means that any additional functionality, such as common methods or attributes, would have to be provided during the metaclass processing to be of any use. I know this might be confusing, and you may not see where this is headed, but just hold on a bit. It will come together in a few sections. With proper attention, a Python class made of concrete can employ a metaclass to resolve both issues. Subclasses inherit characteristics from their parent class. Therefore, the metaclass solution is inherited by all subclasses of a class that has defined it. Let's see a straightforward and effective approach to enable metaclass processing for any class, without requiring each class to individually define the metaclass option. Continuing with the example from the previous section, let's examine what occurs when we create a subclass of real class. Observe how the subclass does not need to be concerned about the presence of a metaclass being utilized in the background. By simply specifying a base class, it inherits all its advantages. Django leverages this behavior to incorporate one of its most notable features, which will be discussed in the following section. Some of Django's more noteworthy tools feature is a declarative syntax that is easy to read, write, and comprehend. This syntax is intended to minimize repetitive boilerplate code and provide clean and readable code. Let's first create a Django project and app to demonstrate what a declarative syntax is. Let's add our app to the installed app in the setting file. And don't forget to migrate the database. Now open the model.py of the application. In the model file, we will add a model class and name it contact. Let's give our class model two fields, a name field and email field. Once you understand how to create a class using declarative syntax, you'll easily be able to create classes using many Django features, both official and community provided. Looking solely at the declarative syntax can demonstrate how simple it is to create a completely new framework for Django that aligns with this structure. Now, let's begin with this centralized access. Usually, a package provides a single module that applications can use to access all the required utilities. This module may import the individual classes and functions from other parts of its directory to maintain readable namespace, but it will gather them all in one central location. After importing, this module offers at least one class that serves as the base class for subclasses in the framework. Other classes are also included to be used as attributes of the new subclass. Together, these objects will determine how the new class operates. The base class. Every feature begins with at least one base class. Depending on the requirements of the framework, there may be more, but at least one base class is necessary to enable this syntax. Without it, users would have to explicitly include a metaclass in every class they define. Apart from examining the defined attributes, this base class will also offer a collection of methods and attributes that the subclass will inherit automatically. Like any other class, it can be as simple or as complicated as needed to provide the necessary features for the framework. Attribute classes. The module that provides the base class will also include a series of classes that can be instantiated, frequently with optional arguments to personalize their behavior, and assigned as attributes of a new class. The functionality provided by these objects will differ considerably across frameworks, and some may function differently than a regular attribute. They frequently collaborate with the metaclass to provide additional behind-the-scenes functionality beyond merely assigning an attribute. The metaclass usually reads options for these attribute classes while creating this additional functionality. For example, Django's model uses the names and options of field attributes to describe an underlying database table, which can then be created automatically in the database itself. Field names are used to access individual columns in that table, while the attribute class and options convert native Python data types to the appropriate database values automatically. Alright guys, we're almost done with this tutorial, so let's see some similarity between Python metaclass and Django model base class. Both Python metaclasses and Django models allow for the creation of classes that can generate instances with similar behavior and attributes. In Python, metaclasses can be used to customize the creation of classes, while in Django, models provide a way to define the structure of a database table. Both Python metaclasses and Django models allow for the definition of attributes and methods that can be inherited by subclasses. Both Python metaclasses and Django models are powerful tools that can be used to define complex classes with a specific behavior and structure. However, it's important to note that while there are similarities between the two, they serve different purposes and are used in different contexts. Python metaclasses are a general-purpose feature of the language, while Django models are specific to the Django web framework and are used for database. So there you have it, folks. We've covered a lot of ground today, and now you should have a solid understanding of Python classes, metaclasses, and Django models. Thank you for your time, and don't forget to subscribe to stay updated.